Hello, in this section, we are going to introduce three data link layer simplex protocols. So these three protocols, they are three of the 6 elementary DLL layer protocols. The first protocol is called an unrestricted simplex protocol. The second one is called a simplex stop and wait protocol. The third one is a simplex protocol for a noisy channel. So we start from the first one. It's also called as protocol 1. It is the unrestricted simplex protocol. So in this protocol, we assume data are transmitted in one direction only. It's always from A to B, that is one direction. Both the transmission and the receiving network layer are always ready, which means if you want to transmit data, it's always there data you can send out. If you want to receive data, there always be a network protocol which are ready to receive the data from the DLL layer. We also consume that the processing time can be ignored, so everything can be done within very, very tiny time. And we consume there is infinite buffer space on the receiver side. The communication channel between the data link layer never damages or loses its frames. So both the sender and the receiver, they are in an infinite while loop. For the sender, it sits in the loop, say, I'm always ready to receive data from the network layer. When the network layer delivers data, I pack the data into frames and then pass to the physical layer. And the sender will sit in the loop, repeatedly do it again and again. For the receiver, it's quite similar. It's sitting in a while loop, always waiting for something to occur. The only thing possibly occur is the arrival of frame. When the frame arrives, the receiver will immediately pass the data field of the frame to its network layer. So it's sitting in the loop, receiving the data, process the data, pass the data to the network layer, do it again and again. So that is protocol 1. Protocol 2, we will drop some unrealistic restrictions. We think the process ability in the receiver is limited. The receiver has only a finite buffer capacity and a finite processing speed, which means it will take some time to the receiver to process the data. If there's too much data to be handled, and if the receiver does not have enough time to finish all the data should be buffered, because the buffer size is limited. When the buffer is full, then the data will be lost. So the question is how to prevent the sender from flooding the receiver with data. So don't let the sender send too much data that the receiver cannot handle. There are two possibilities we can do to avoid this problem. Solution 1, we simply insert a delay into protocol 1. So after the sender finishes sending a frame, the sender will wait a while. The problem of this solution is how long we should let the sender to wait, how long the delay should be. If the delay is too long, then it will hurt the performance. If the delay is too short, then you probably will still flood the receiver. So the second solution is to let the receiver provide feedback to the sender. The protocols in which the sender sends one frame and then waits for an acknowledge before processing the next frame is called stop and wait. So that is protocol 2. We now look at protocol 3. We should consider something more realistic. In the normal situation, a communication channel may take errors. We are trying to look for a scheme using timer and acknowledgement to handle errors. The scheme works like that. The sender starts a timer after sending a frame. the receiver sends back an acknowledgement only when the incoming frame was correctly received. The sender will retransmit the frame if the timer expired before. There might be a fatal flaw in this above scheme. If we don't receive an acknowledgement, the sender will retransmit the frame, but it will end up with there will be several duplicated frames received by the receiver. So for the receiver, the question is how to distinguish a frame being seen for the first time from a retransmission. In order to solve this question, we can use a sequence number in the head of each frame. So when the receiver receives a frame, the receiver will check whether this is a new sequence number, whether this is a sequence number it has never seen before. In the end of this section, there is a question for you to think about. This is about Protocol 3. What can be the main disadvantage of Protocol 3? So that's it for this section. Thank you.